Good afternoon to Dr. Fuad and to everyone. Today, our group will be presenting a benchmarking analysis where we compare the hardware performance of our laptops using different tools and tests. Before we begin, we will introduce ourselves. My name is Afifa Nazneen binti Bashir.
My name is Shazina Marsha bint Sharizain.
And my name is Azralin Anak Perempuan Dialan.
My name is Siti Maisarah binti Ahmad Arsmi.
Now, I'll be starting with our project introduction. And the purpose of our project uh, is to benchmark and compare the performance of each member's laptop. And our background is in today's technology-driven world, evaluating computer performance is essential to ensure systems run efficiently under different workloads. Benchmarking uses standardized tests to simulate real-world tasks, allowing for objective performance comparisons and detection of bottlenecks. This project explores benchmarking tools to better understand how hardware specifications and software behavior affect system performance. Our aim is to evaluate and compare CPU and hardware performance using free benchmarking tools in order to understand how system specifications involves real-world performance. And we have four objectives. The first one is to understand the principles of CPU and hardware benchmarking. The second one is to compare performance across different computers. Third one is to analyze how various workloads affect system resources. And the fourth one is to gain hands-on experience using benchmarking software.
So in this project, we benchmark 3 laptops running Windows OS. We use CPU ZEC to extract hardware spec, Geekbench for CPU performance testing, Windows Task Manager to monitor system behavior under varying workloads, and MiniTool Partition Wizard to test this read or write speed. The results were compiled, compared, and analyzed to understand how hardware specifications affect performance. So, we use CPU ZEC to extract detailed specs like clock speed, cache, and core count, and it also helps us perform basic CPU benchmarking. Next, we use Geekbench for a more intensive performance test to test single core and multi-core capabilities under simulated workloads involving maths and cryptography. To monitor the system's behavior during this task, we use Task Manager, which show real-time usage for CPU, memory, disk, and GPU. Lastly, we ran MiniTool Partition Wizard to test this performance, both sequential and random read or write speeds.
So now I'll be explaining about our team's computer specifications. So our team uses 3 laptops, and the first one is Nazneen's laptop, and the CPU model uses AMD Ryzen 5, and it's 8 GB for RAM, and it uses SSD for the storage time, and Windows 11 for the operating system. And the second one is Masha's laptop, which uses Intel Core i5 1335U, and for RAM it's 16 GB and uses SSD as the storage type and use Windows 11 also as the operating system. And the last one is my Sarah's computer, which uses AMD Ryzen 5 also, and 16 GB as the RAM also, and storage time and the OS are the same also, which is SSD and also Windows 11.
So now here is ASM benchmark execution result. So basically from the graph and from the table, we can see that how the CPU time increases with loop count. So and then we can see that growth becomes exponential at higher loop counts, and performance bottlenecks appear beyond 500 loops, and this also highlights the importance of code optimization. So for example, we can see from the table, we can see for 50 loops, the CPU time is around 2151 milliseconds with a very low load level. From this, we can observe that it has fast execution and minimal CPU effort. So basically, in other words, this CPU has less strain from when we compare to the other loops like loops 100, 200, 500, 700, and also 1000. So another example we can also see from the 100 and 100 loops and 200 loops with a different CPU times. For 100 is 6,393 and for 200 is 12,371. With the load level of low and moderate, we can see the observation from this. It is that these are still considered efficient and manageable, even though from the 100 we can see the slight increase, and 200 there is still noticeable growth. And for the loop 500, the CPU time is 31,769 with load level moderate. It has a larger delay, and we can see that it starts to affect the performance of the laptops. And as the loops goes higher, we can see there are more slower response, as we can see from the loop of 700, and we can start to see that CPU strain is more visible than lesser loops. And lastly, for 1000 loops, we can see that the CPU time is 62,056 millisecond. And the load level is very high. So from this, we can see the observation is sharp increases and heavy CPU workload.
So now we'll be moving on to our benchmark results. And our first result is from our CPU Z. And these are the information that we got. So if you see that Nazneen and Maisara's laptop, the CPU model is AMD Ryzen 5, and Masha's laptop is Intel Core i5. But the value of cores differ from laptop. So Masha's Intel i5 has the highest core count, which is 8 cores, which is ideal for multitasking and multi-threaded programs. And for clock speed, we can see that Nazneen's laptop has the fastest clock speed and has the largest L3 cache, which is good for single thread tasks, which means Nazneen's laptop can retrieve data faster than other laptops. And Maisara's laptop has balanced specs, solid performance with decent clock speed, cache, and more RAM. So Maisara's laptop is actually very balanced, not too, the value is not too high or not too low. But in terms of RAM, Masha's and Maisara's RAM is actually higher than Nazneen's laptop, which they have 16 GB and they support heavier apps and multitasking more efficiently than 8 GB RAM.
So here are the results from the Geekbench CPU for performance tests. So from the table, you can see that Nazneen's laptop scored the highest in both single and multi-core tests, indicating it performed best for both light and heavy workloads. And Maisara laptop showed solid performance, especially in multi-core tasks. Her score indicates that the laptop is capable of handling multitasking and general everyday use efficiently. And Marsha's laptop has the lowest score, which may result in slower performance, but it's still suitable for basic computing needs like browsing or documents.
Now moving on, we will see the benchmark results using the MiniTool disk performance. So for Nazneen's laptop, the sequential read is 523 and 0.755 and the sequential write is 1512 and the random read is 1034.76 and the random write is 1442.62. This shows that Nazneen's SSD consistently performs best in both sequential and random read and write tests, which is ideal for task reading, fast disk access like file-heavy apps or quick boot times. Meanwhile, Marsha's SSD offers reliable and mid-range performance, which is good for typical user needs like browsing or saving files and running multiple apps. Maisara shows excellent read speed, especially for large files, but it's inconsistent with its write speed, which may affect tasks like installing software or transferring many small files.
So the next one is benchmark results for task manager workload stress. So from the table, we can see for Nazneen's laptop, we can see that under low load apps, we can see from Nazlin's laptop uses 58% RAM usage with just a basic apps like Microsoft Word and snipping tools. And for Marsha, for low load apps, she uses a WebEx and Window Explorer that only uses RAM usage of 48%. And so for Mysara laptops, you can see that for low load apps, she opened Task Manager and Windows Explorer that only uses 49% of the RAM. And next one is the high load apps. For Nazneen, we can see that for high load apps, we have Google Chrome, Microsoft Edge, Minecraft Education, Snipping Tools, SpongeBob Krusty Cook Off, and Spotify, which only uses RAM of 90%. And for Masha, we have Canva, Google Chrome, Microsoft Word, Spotify, Telegram, Desktop, Visual Studio Code, and WebEx, which only uses 78% of the RAM. And for Mysara, we have Google Chrome, VS Code 2019, Task Manager, Visual Studio Code, Windows Explorer that only uses 73%. So from here, we can see that Nazneen's laptop has consistently high RAM usage at all load levels, which may mean more background activities or less efficient memory management. And for the next one is Marsha. Marsha performs moderately better than Nazneen, but not as optimized as Maisara under heavy workloads. And lastly, for Maisara, it demonstrates the best memory efficiency, especially under high stress. This suggests it can handle multitasking more effectively.
Okay, so now we will move on to our discussion part now that we have seen our results. And the first discussion is we are going to discuss about the CPU performance. And as you can see here, we have listed all the CPU model, cores, clock speed, single core and multi-core. And if you see the bar chart on the right, we can see the difference in the core value, the score for single core and multi-core. And as you can see, Nazneen's laptop has the highest multi-core and single core, followed by Maisara and Masha's laptop. So based on the results, we can see that Nazneen's laptop leads in CPU performance due to its strong single and multi-core scores. This makes it suitable for demanding tasks like content creation or multitasking. Meanwhile, Masara's laptop also shows reliable performance for development work and multitasking, even though it's slightly behind in scores. And lastly, Masha's CPU, despite having more cores, but the single core and multi-core is way weaker. So it shows the weakest performance overall. And this might be due to its lower base clock and less efficient single thread performance, but still can be used for basic tasks. But Masha's laptop might struggle with heavier workloads.
So next, we evaluated this performance, focusing on the read or write capabilities of the SSD in each laptop. So Nazneen laptop uses a Micron NVMe SSD, which gave the fastest read and write speeds. It also showed excellent responsiveness, making it ideal for booting up and managing files efficiently. Next, Marsha's laptop using Samsung SSD, which provided a balanced and steady performance, although it shows lower peak speeds compared to Nazneen. Still, it's reliable for general tasks. Next, Maisara's laptop, which has strong read performance thanks to its PCCN740, but the write speed were inconsistent, which could affect performance in tasks like saving large file or software installation. In summary, Nazneen device offer top-tier disk speeds, and Marsha delivers consistent mid-range performance, while Maisara is good for reading but may lack in writing operations.
So now we will see the discussion about memory usage. So for Nazni, we can see that her RAM is 8 GB and her low load is 58% and her high load is 90% and her efficiency is the lowest, which means Nazneen got great CPU and SSD, but due to her limited RAM, it affects her multitasking. And for Marsha, she has good RAM, which is 16 GB, same with Maisara, but she got slower CPU and SSD compared to Nazneen. While for Maisara, she has the best memory efficiency and solid performance and well-rounded option.
So in conclusion, we can see from Nazneen's laptop, it has best overall CPU and SSD performance, ideal for heavy tasks, for example, like content creation and multitasking. And the limitation is only 8 GB RAM, may struggle with memory heavy workloads. And the second one is Marsha's laptop with 16 GB RAM and 8 core CPU support multitasking. The limitation is weaker CPU and SSD reduced speed in demanding apps. Lastly, for my Sarah's laptop, it has the most balanced performance, efficient memory usage, and strong read speeds. But the limitation is it has inconsistent write speeds for large data tasks. So no single laptop is perfect for all tasks. Each has strengths based on use case, CPU speed, core count, RAM, and SSD all play different but important roles. Benchmarking helps make smarter hardware decisions for different needs.
And finally, for our reflection, I will start with my reflection first. So throughout this benchmarking project, I learned how to use different tools to measure a laptop's performance, including memory and storage. I now understand how parts like RAM, SSD, and processors work together. Analyzing my own and my friends' laptops' performance made me realize which specifications to consider when choosing a device that fits my needs. This experience improved my understanding as a computer science student and made me more interested in hardware. It also taught me the importance of teamwork, especially during completing technical tasks.
Next, through this project, I learned how to benchmark my laptop performance using MiniTool Partition Wizard, CPUZack, and Geekbench. And by testing different transfer size and analyzing both sequential and random read or write speeds, I gained a better understanding of how storage affects system performance. And I also learned how to interpret benchmark results and relate them to real-world usage like file transfers and multitasking. Overall, I think this project helped me improve my technical skills and understand the importance of this performance in computing.
As for the reflection, for me, through this benchmarking project, I understand how the CPU, memory, disk, and the motherboard affect the overall performance of a computer system. I learned how to benchmark my laptop using ASM code too, which gave me a better understanding of the assembly language. It was a valuable experience to work with my fellow team members and to do this project together.
As for me, this benchmarking project has given me a clear understanding regarding how hardware specification brings quite an impact towards system performance. By using tools such as CPU-Z, Geekbench, and MiniTool Partition Wizard, I was able to evaluate how CPU, memory, and storage respond under various workloads. Thus, this has hands-on experience improved my ability to analyze computer system performance and strengthen my understanding towards the connection between hardware and software.
I think that is all for our presentation video. Thank you so much.
Thank you.